Okay, so now we're going to try and solve one that has an oblique asymptote, which we didn't do in class. The function is 2x squared minus 3x minus 5 over x minus 3. Let's see how it goes. The first thing we're going to do is we're going to talk about the domain of the function. So the domain, if you remember, you're going to take the bottom and set it not equal to 0. So I'm going to take x minus 3 not equal to 0. So x can't be 3. What we know now is that at 3, something funny happens. We don't know what it is yet, but it's probably an asymptote. We'll find out in a minute. Now we're going to look at the intercepts. The y-intercept is going to be f at 0. As we talked about in class, that blanks out everything but the constant, so I'm going to get minus 5 over minus 3, which equals 5/3. Okay, so that's going to be at 1 2/3, which is roughly about here. Okay, so far that's what I have. Next, I'm going to find the x-intercepts. For the x-intercepts, I'm going to take 2x squared minus 3x minus 5 and set it equal to 0. That factors very nicely into 2x minus 5, x plus 1. So x is equal to either 5/2 or x is equal to minus 1. Okay, so when you look at that, 5/2 is going to be around 2.5, which is right here. Or x is equal to, as I said, -1, which is going to be roughly around here. Okay, so that's what we have right now. Next, what are we going to do? Well, we have the intercept, we have the domain, now we're going to look at asymptotes. The vertical asymptotes are the easy one. What do we do for vertical asymptotes? We take whatever is not part of the domain and make sure that it doesn't make the numerator 0. So x equals 3 is our candidate. We see that it's not a 0 on the top, so it is indeed an asymptote. So I'm going to put it right there. I'm going to bring it all the way up there. Now I know the function's up there already, so I'm not going to worry too much about doing the bottom too easily. I'm going to label it though. X equals 3. Now, for the other asymptotes, either vertical, rather horizontal, oblique, or functional, we're going to have to perform the division. We know that it's not horizontal because the degree of the top is bigger than the degree of the bottom. So I'm going to go ahead and divide, and I'm going to use long division, even though synthetic division would work just as easy here. I'm going to take x minus 3 here. I'm going to take 2x squared minus 3x minus 5. Put it in there. I've got 2x here. I get 2x squared minus 6x. When I subtract, I'm going to get 3x here. I'm going to put plus 3. That gives me 3x minus 9 here. And that gives me a plus 4 there. What that tells me is that my function f of x can be written as 2x plus 3 plus 4 over x minus 3. That means that this right here is my asymptote, since this would be going to 0 as x gets bigger. So I'm going to have to graph y equals 2x plus 3. So 1, 2, 3 roughly. There. For every 1 I go over, I go 2 up. And my line looks very roughly like this. I will label it as y equals 2x plus 3. Okay. From here on out, all you can do is plot points, and what's going to probably happen is that this function will look like this up here, and it over here is going to kind of mirror this right here. Hit the 0, come back down, and approach it that way. I have it in my calculator just for fun. I put it in there. Let's take a look and make sure that it is indeed that graph. And when you look at it, it sort of looks like that. It's a little wider on the calculator because of the way I did it, but other than that, we see that we got the right graph. Alright, well, thank you for watching this, and hopefully it'll help you with some of your homework. Have a nice day.